This video is part of our course on modern C++, which goes from the absolute beginning all the way to a point where you can use advanced features of the C++ programming language. We even cover the 4 big features in C++20, and that is concepts, ranges, coroutines, and modules. And we have a bunch of exercises to really help you nail this down. Please do check this course out if you are interested in this, and you can also check out what others are saying about the course here. The link is going to be shared in the description below. In this lecture, we're going to learn about masks. Masks are a way we can highlight or shadow bits in a byte. Here we have what we can consider as a byte, and if we want to highlight the bit in position 0 here, we can do it like this. We can set up another byte and call it mask like this, and we're going to highlight the bit in position of interest inside our byte. In this case, we are interested in the bit at position 0. We're going to make it a 1, and all the other bits that we're not interested in are going to be set to 0. This is a convention we use with masks, and having this convention in place is going to allow us to do a set of operations on our bytes in a unified manner. And you're going to see what we mean in a minute. For now, let's familiarize ourselves with how we can work with these masks to do things. Here is another example in which we are highlighting the bit in position 1. Again, the mask is set to 1 in that bit position, and all the other bit positions are set to 0. We can do the same for bit in position 2, the same thing for bit in position 4, and we can keep going on highlighting the bits that we are really interested in. And notice that in this case, each mask is going to only be highlighting one bit, and all the other bits are going to be set to 0. This is going to allow us to do things in a much more flexible way. Once we have all the masks we need in our application, we can store them in variables like this. If you look here, we have a few unsigned car variables. They are flagged constants because we don't intend to modify these variables. And each of these variables is going to be 1 byte in memory, which is really going to be 8 bits. And it is going to be storing the data to highlight the bit in a byte that we want to manipulate. So for example here, mask bit 0 is going to be highlighting the bit 0. All the other bits are going to be 0. Mask bit 1 is going to highlight the bit in position 1, and all the other ones are going to be 0. And we're going to keep going until we hit mask bit 7, which is going to highlight the bit in position 7, and all the others are going to be set to 0, or they are going to be shadowed if we want to say it like that. Okay, once we have the masks stored like this, we can use them to do a set of operations. For example, we might want to set different bit positions in our byte. And by set, I mean making the value inside a 1. We can also reset bit positions by setting the value inside to 0. We can check the value inside a bit position in case we want to know if it's a 0 or a 1. And we can toggle bit positions. And by toggle, we mean the possibility to change the bit inside there. If it's a 0, we change it to a 1. If it's a 1, we change it to a 0. And that's called toggling. Let's look at an example. And in this case, we are interested in setting the bit in position 0 in our gray byte here. So the first thing we will do is set up a mask that is going to target that bit. And the mask is what you see here. The bit of interest is highlighted, it's set to a 1, and all the others are going to be set to 0 or shadowed. To use this mask to set data in our gray byte here, we're going to do an operation. And the operation we're going to do is bitwise OR. When we do this operation, the bit in the position of interest is going to be changed to a 1, regardless of the value we have in our gray byte here. So if it's a 0, we're going to OR that with a 1, and we're going to get a 1. If it's a 1, we're going to OR that with a 1. We're also going to get a 1. But notice all the other positions. Because we're going to be ORing with 0, we're going to keep the values the way they were. If we take 0 OR with 0, we're going to get 0. If we take 1 OR with 0, we're going to get a 1. And we're going to keep doing this until we hit this bit here. And everything that is not highlighted is going to keep whatever data was in there. And effectively, we have only set the bit of interest, which is really what we wanted. And this is really powerful. I hope you can see this. Let's look at another example in which we are interested in setting the bit in position 1. The first thing we're going to do is set up a mask, and we're going to do the mask here in blue. We're going to highlight the bit in position 1, and we're going to do our OR operation. If we do that, the bit of interest is going to be ORed with 1. The result is going to be a 1, but all the other bits are going to stay the same, and this is really what we want. We can do the same with bit in position 2. We're going to set up a mask. We're going to highlight the bit of interest. We're going to leave all the others with a 0. And if we do the OR operation with the mask, the bit of interest is going to be set. All the others are going to remain with whatever it is was in there originally. Okay, you might be asking, this is all good and interesting, but how do I do this in C++ code? Well, I'm glad you asked. Here is a simple example of how we can do this. We have a variable, it's unsigned car, and we may use our new technique to set the bit in position 1. The first thing we would need to do is to set up a mask. And if we go back here, you see that we have set up a few masks beforehand. If we are interested in setting the bit at position 1, we're going to use our mask bit 1 here. Okay, so now that we have the mask, we can set bit at position 1. And what we're going to do is compound bitwise OR with mask bit 1. And we're going to store the result back in var here. And if we print this out, we're going to see our result with the bit in position 1 set. We can really do the same thing with the bit at position 5. We're going to use the mask bit 5, and we're going to do a bitwise OR operation and store the result back in var. And if we print this out, we're going to see our result. We can also reset bit at a position of interest. And here we're going to be reusing the same masks. What is going to change is the operation we do. So what we really want is some operation we can do with the 1 so that we can get a 0. And hopefully you might have an idea about how we would do that. If we take this 1 and with a 0, we're going to get a 0. But to get a 0 in this mask, we have to kind of reverse it. And we have a bitwise operation to reverse an entire byte. And that's the bitwise NOT operation we can run on this mask. And then we're going to bitwise AND it with our gray byte. And we're going to get the result in this result byte here. So if we reverse the mask, the bit of interest is going to be 0. All the other bits are going to be set to 1. And if the bit of interest is ANDed with 0, we're going to get a 0. So we have reset it. But all the other positions are going to be 1s. And notice what happens if we AND our gray byte with a 1. So 0 and 1 is going to be 0. 1 and 1 is going to be 1. 1 and 1 is going to be 1. So effectively, we are going to keep all the other bits the same. And this is really cool. We have only affected the bit of interest and we have reset it. We can do the same kind of operation on bit at position 1. And it's really going to be the same. We're going to reverse the mask. And after we reverse the mask, we're going to AND the result of that with the gray byte. And the bit at position 1 is going to be set to 0, but the rest is going to remain the same. We can also do this at another byte of interest. For example, this position is 0, 1, 2, 3, 4, 5. If we do this, we're going to set it to 0, and all the bits are going to remain the same because we have done a bitwise AND with the reverse of the mask. Here is an example of how we can do this in code. It really is the same things, but we have changed the operations we do. We are going to AND with the reverse of the mask. This is another example of how we can reset the bit in position 5. We're going to AND it with the mask that is reversed, and we're going to print out the result here. This is really easy once you understand what is happening behind the scenes. One thing I want you to see is that we can also mask multiple bits at once, and we achieve that by taking our masks and bitwise ORing them together. Here you see that we have mask bit 0 all the way up to 7. So this is going to mask and select the entire byte. And we can do operations on it. For example, we can set all bits, and this is going to do what we want. If we print this out, this is going to show that all the bits are set to 1. We can also reset a selected number of bits in our byte. For example, here we are interested in 0, 2, 4, and 6. We can do our mask here that is going to combine all the masks, and we're going to do the operation we do to reset, which is ending with the reverse of the mask. And we're going to get what we want. Another operation we can do is check the value in a position and know if it's a 1 or a 0. What we're going to do is use our mask. We're going to select the bit of interest. In this case, it's bit 5, I guess. 0, 1, 2, 3, 4, 5. Yes, it is. And after we have the mask, we're going to end the gray byte with the mask and shift right the amount of the bit position. And why do we do that? We want this bit of interest to be in position 0 so that the byte can be interpreted as an integer. So if we get 0 in the integer, the bit is not going to be set. If we get a 1, the bit is going to be set. So let's go through this again so that you really understand it. We have our gray byte here. We have our mask, which is going to highlight the bit at position 5. We're going to end with the gray byte here, and the result is going to be 1 at this bit position. What we're going to do, we're going to shift this right 5 times, and we can do this 1 time, 2 times, 3 times, 4 times, 5 times. This is going to end up in bit position 0, and if we interpret this result byte as an integer, we're going to get a 1, and that's going to tell us that this bit here was set. If we had a 0 in here, we would have ended up with a 0 in the result. If we shifted that 5 times, we would end up with a 0 in this bit position 0, and we would interpret this result as a 0. Here is how we can do this in code. If you look, we are printing things out. We are saying bit 0 is, we're going to take var, end that with the mask, and we are going to get our result printed out. For example, for bit 1, we're going to take var, end that with the mask bit, and we're going to shift right 1 time, and we're going to keep increasing the number of bits we move, and we're going to get integers, and we're going to print them out. If we want to interpret these things as booleans, we can take these integers and cast them back to bool using our static cast like we have learned before. And this is going to give us what we want. I realize these things may be not making sense for complete beginners, but we're going to have a chance to play with this in Visual Studio Code, and I am sure you're going to understand. The next operation we're going to look at is toggling. And toggling really is changing or flipping the bit we have in our gray byte here. If it's a 0, we're going to turn it into a 1. If it's a 1, we're going to turn it into a 0. And the first thing we need to do again is to set up a mask. We're going to target the bit in position 0. The operation we're going to do is XOR. So check how this thing works. If we have a 1 in the gray byte and we XOR that with the mask, we're going to get a 0. So it is going to be flipped. And the rest of the shadowed bits are not going to change. Let's try this out on a couple of bits. For example, 0, 0, 0 is 0. It's not going to change. 1, 0, 0 is 1. It's not going to change. And the rest is really not going to change because it's going to be the same operations that we repeat. So this is going to effectively be toggling the bit in the position of interest. And this is how we can do this using a mask. And again, we can do this in C++. By doing exactly the same operations, we are going to XOR with the mask of interest, and the result is going to be stored back in var, and we can print it out. Okay, we have seen a lot of operations. I think it's time we went to Visual Studio Code and actually saw this in action. Here we are in Visual Studio Code. We're going to work on this lecture here that says masks. We're going to grab our template code. We're going to put that in our folder here, and we're going to open this up in Visual Studio Code pretty quick. We're going to open the folder. We're going to open masks, And we're going to open main CPP and take out what we don't need. The first thing we want to do is to include IO manip because we're going to need it, and we're going to need bit set. So let's do that. We are going to go down and put in our code. We're not doing anything special really. We're going to set up our masks. We have a variable for the column width to have things aligned nicely when we print them out to the console. We're going to have our sandbox variable, which is going to be what we're going to be manipulating with our masks. And we can print this out, the initial value of it. Let's try this out. We're going to bring up our terminal. We're going to build with GCC. And if we run this, we're going to get our variable to be 0 here. And this is what we have in here. The first operation we want to do is to set a few bits. And we're going to effectively make them ones, regardless of what's in there. We are going to do the same thing we exactly did in the slide. So we're going to set the bit at position 1. And the operation we do, we're going to OR with the mask bit. Bit 1 is going to be highlighted by the mask bit 1 variable, which we have in here. So let's make everything really visible. We're going to click here and hide this pane here. And here you see that we're going to do the OR operation with the mask bit 1. And this is effectively going to set the bit in position 1. And that's going to be this bit here. I don't know if you can see in Visual Studio Code because it's really small, but it is the bit in position 1 here in our output here. So if we print this out, we should see a 1 in this position. Let's do that. We're going to build with GCC and we're going to hit rooster. If we do, this bit is going to become a 1. It was a 0, so it was successfully set using our technique here. We can also set the bit in position 5, which is what we've seen in the slides. We're going to do it like this. We're going to do the bitwise OR operation with the mask bit of interest, and it is going to be mask bit 5. And we're going to print this out because the result is being written back in var here. So we're going to build and see this in action. Let's bring this up a little bit so that we can actually see. We're going to run rooster, and you're going to see that the bit in position 5 is set. And we can count here 0, 1, 2, 3, 4, 5. This is exactly what we expect, and it is working. We have also seen that we can reset bits of interest. We are going to be reusing the same masks, but the operation we're going to do, we're going to end with the reverse of the mask. That's what we're going to do here. So if we are interested in resetting the bit in position 1, we're going to do the bitwise AND operation, and we're going to do that with the reverse of mask bit 1. If we do that, we're going to get the result that we expect. So the bit in position 1 is going to be set to 0, even if it's a 1. So we can try running this. We're going to go to terminal. We're going to run the task to build with GCC. And we are going to see that the bit in position 1 is reset to 0 down here. How cool is that? We can also try another example. We're going to reset the bit in position 5 and bring that down to 0. We're going to do exactly the same thing, only now we're going to be using mask bit 5, which is going to highlight our bit of interest. If we try to build and run this, and we're going to get all bits set to 0 because we just brought down the only bit that was on in this byte here. How cool is this? We have also seen that we can combine our masks and make them do things in one go. For example, if we want to set all bits at once, we can combine our masks with the bitwise OR operation. And if we do this, we're going to be ORing this with the combined mask, and this is going to set all the bits. If we print this out, we're going to see all ones. So let's do this. We're going to build and we're going to run rooster. We get all ones. This is working. We can also reset a few bits. In this case, we are interested in bits 0, 2, 4, and 6. So that's what we're going to use for the mask, 0, 2, 4, and 6. And the operation is going to be the operation we did for resetting. And for that, we did a bitwise AND with the reversed mask. If we print this out, we're going to get our bits of interest reset. So we're going to build with GCC. and we're going to run this, and we're going to get our bits of interest reset. You see that position 0 is reset, position 2 is reset, position 4 is reset, and position 6 is reset. Another operation we could do with our masks was to check the state of a bit to know if it is a 0 or a 1, and we saw a trick for that, which was ending with the mask and shifting a given amount of bits to force the bit of interest in position 0 so that we could interpret the entire thing as an integer. Let's run this so that we can see it in action. I have to prove that this actually works. So we're going to go up again, click on the terminal and run Rooster. And let's bring this up again a little bit. So this is the data we had before we do our check here. And you see that it is true. Bit 0 is 0, bit 1 is 1. Bit 2 is 0, bit 3 is 1, bit 4 is 0, bit 5 is 1, bit 6 is 0, bit 7 is 1, but we are printing 6 and 7 two times because we had to turn them into Booleans. So if we had something set up here to force Boolean output to true and false, and we can actually do that. So let's do std bool alpha. We should see trues instead of ones. So let's do alpha actually. And if we build again, we're going to build with GCC. We can run Rooster and we're going to get what we want. Bit 6 is false, bit 6 is 0. We could either interpret this as an integer or explicitly cast this to a bool if bool is what makes sense for whatever it is we are building. But you can see that this technique is effectively getting the value in a given bit, and it is working pretty well. Let's go down and do the last thing we're going to do in this lecture, and that is toggling bits. The operation to toggle was to do the XOR with the mask, and we're going to use whatever mask we need to target our bit of interest. So in this case, we want to toggle bit in position 0. We're going to use the mask in bit 0. And if it was a 0, it's going to become a 1. If it was a 1, it's going to become a 0. We can prove this. So let's build, and we're going to run Rooster. We're going to see that the data we had before we toggle was, let's go up and actually make sure this is visible. Let's clear again and run Rooster so that we don't have too much noise. So the bit in position 0 was 0, but now it's a 1. So this is really working. We are toggling. We can also toggle bit 7. Why not? So bit 7 was a 1. It's going to become a 0. Let's build this. We're going to run the task to build with GCC. The build is going to go through, and let's bring this up so that we actually see this better. We're going to clear, and we're going to run Rooster, and we can successfully toggle our bits using our technique here. Just as an exercise, I am going to show you that we can also toggle bits in one go, and for that we're going to combine our masks to target all the bits of interest in one go. In this case, we want bit 7, 6, 5, and 4, and we want to toggle them. So we're going to XOR with whatever data we have in var, and if we print this out, we should have all these upper bits flipped off. So let's do that. We're going to build with GCC. We're going to bring this up a little bit, and we're going to clear again and run Rooster. And we're going to see that we're going to change the map. We had a 0010, now we have a 1101, and we have successfully flipped off these bits. This is really powerful stuff. Okay, this is really all we set out to do in this lecture. I apologize because the lecture turned out to be really long, but I had to show you these things in one piece of video so that you have one place for reference, and I hope you really found this interesting. We are going to stop here in this lecture. In the next one, we're going to actually see an example of how this can be useful. Go ahead and finish up here and meet me there.